So today we're going to go over the Chapter 7 practice test. The actual Chapter 7 test that we're going to take tomorrow is almost exactly like this. It's the same type of problems. It's the same number of problems. The problems are just a little different. Like instead of maybe like x plus 5 times x plus 2, it'll be x plus 9 times x minus 1 or something like that. So they'll be the same type of problem but not the exact same problem. So I want you to go through and grade it and write the correct answer. So let's say you got number 2 wrong. Put a big X on number 2 so that you know tonight when you're studying that you need to go back and rework number 2 until you get the correct answer. So I want you to somehow indicate which ones you're missing, which ones you're getting wrong, but also write the correct answer so that you can check your work and make sure you're doing it right later when you're studying. Any questions before we get going?
Can I get another one?
Sure. Alright, so the first one, we have a binomial times a binomial. When we have that, we double distribute. So x times x is x squared, and x times 2 is 2x. We also distribute the 5. So 5 times x is 5x, and 5 times 2 is 10. These are like terms in the middle, so go ahead and add them. That gives us x squared plus 7x plus 10. So if you did not get that, somehow indicate to yourself, hey, I need to go study this one tonight, and write the correct answer so that you can go back, rework the problem, figure out how you're going to get the right answer tomorrow. Same thing on number 2, we're double distributing. So 4x times x is 4x squared. 4x times a negative 2 is negative 8x. Negative 3 times x is negative 3x, and negative 3 times negative 2 is plus 6. In the middle here, they are like terms. They're also both negative, so we're going to add the numbers, keep the negative sign. And there you go. Number 3, we have a monomial times a binomial, so you just have to single distribute. That gives us 7x plus 14. And then number 4 is not actually ready for double distributing. You have to recognize that that whole quantity, what's in parentheses squared, means that you have x plus 6 times x plus 6. X plus 6 multiplied by itself twice. Distribute x times x is x squared. X times 6 is 6x. 6 times x is 6x. And 6 times 6 is 36. Go ahead and add those. We get x squared plus 12x plus 36. Alright, so number 5, again we're going to double distribute. X times x is x squared. X times 7 is plus 7x. Distribute the negative 7 as well. Negative 7 times x is negative 7x. And negative 7 times positive 7 is negative 49. We've got like terms in the middle here. That's going to be x squared minus 49 because 7x minus 7x is 0x. And you don't need to write 0x. You can just leave the x term out. Notice, like, this problem is a difference of squares, right? This is x squared minus 49. This is like a problem you'd see in the last section on the test, and this would be the answer that you give. So they just work in reverse. So when we're double distributing, we end up with the x squared minus 49. We end up with a difference of squares. If I give you a difference of squares and ask you to factor it, then that's when you have an x minus a certain number, x plus a certain number. Alright, I am going to distribute the 3x on the next one. 3x times x is 3x squared. Minus 3x times 8 is 24x. No like terms, nothing else to distribute, so we're done on that one. Number 7 is a pretty simple one as well. We're just single distributing. It's a monomial times a binomial. So 4 times x is 4x. And 4 times 10 is 40. And then the last one on the distributing section, it's a monomial times a trinomial. So you're just distributing the 6, but you're distributing it to 3 different terms. So check those out. Let me know if there's anything we need to discuss. So this next section, the directions tell us to find the GCF. So the next section says factor the GCF. When we're factoring, that's when we go through and we divide and we rewrite it using multiplication with parentheses. When you're just finding the GCF, you're just finding the GCF. Okay, don't make this harder than it is. These are the simple ones. So to make 3x squared, we have 1 and 3, we have x and x. To make a 14x, we have 1 and 14, 2 and 7 with an x. What do they have in common? 1x, 1x. 1x is the same thing as x, so if you just want to leave it as x, that's fine. If you want to leave it as 1x, that's fine too. Don't distribute or don't divide, don't write with parentheses, that's it. Alright, number 10, we're going to do the same way. Notice how important the factor sheets are. I do not have any more factor sheets. I will not have any more factor sheets. You need to get your own factor sheet between now and the test tomorrow, or you're going to have to make all these lists up in your head. Which, I mean, it's not impossible. It's just a lot of extra work. I don't know why anyone would want to do all that extra multiplication. I mean, I enjoy it, but I'm a math teacher, so. Alright, number 10 is taking a little more space than I anticipated. Alright, so what's the biggest number they have in common? 6. Good. Yeah, they both have 2 x's, so x squared. And then the first one just has a single y, so y, just one y from each. Alright, so 6. X times x is x squared, and then the y. Any questions on how I got that? Alright, next one we have 8x. That's 1 and 8, 2 and 4, x. We have 16y. That's 1 and 8, no, 1 and 16, 2 and 8, 4 and 4, and y. So what's the largest number that's in both?
8.
Alright, number 12, we have 15x. That's 1 and 15, 3 and 5, x. We also have, let me see if I can squeeze it in over here, 35y. That's 1 and 35, 5 and 7, y. What do they have in common? 5. Notice these last two did not have any variables in common. They both had a number with an x and a number with a y. Remember, they have to be common factors. Greatest common factor. With the biggest numbers that they have in common. Alright, GCF. You can't factor GCF on the next page unless you know how to do this. Find the GCF. So what are your questions on finding GCF? Really good question. What was the question? I don't know why I wrote a Y. The question was write your Y to Y. Why the Y? I don't know why the Y. Okay? I just got done saying that there are no variables, but then I wrote a Y. So back it up, cross it out. It's just 5. This one doesn't have a Y. Just keeping you on your toes. Only one of you passed the test. Way to go.
No.
Way to go.
I'm
All right. Any other questions? Sorry about that.
Oh, my bad. My back really gets hurt.
My whole YouTube channel doesn't need to hear about your back. Okay? All right. Let's get going to the next, to the back. All right, so number 13, a lot of people were struggling to find the GCF here, which it's actually, I think, a little easier to find the GCF here. 17 is prime, so it's 1 and 17, and then you just have the x. Technically, you have a 1 in front of these x's as well, so what's the GCF? 1x. 1x is the same thing as x, so I'm actually just going to write it as an x, but if you want to write it as a 1x, go for it. So remember, when you're factoring means you're rewriting it as a multiplication problem. So we have the GCF in the front, and then we're going to divide each term by that GCF. We're going to write the leftovers in parentheses. If you have x squared and you're taking an x to the front, what do you have left? Just an x. If you have a 17x, but you're taking the x to the front, what do you have? 17. There you go. Bless you. Next we have 12x and 9. So we have 1 and 12, 2 and 6, 3 and 4, x. We also have 1 and 9, 3 and 3. No variables. So what's the GCF? 3. So I'm going to divide everything by 3. Write the 3 in the front. 12 divided by 3 is 4. You have the x with it. 9 divided by 3 is 3. Remember, you can always distribute on these. Like 3 times 4x is 12x. 3 times 3 is 9. If you distribute and you don't end up where you started, you've made a mistake and you need to redo it. Alright, next we have 4x squared, so that's 1 and 4, 2 and 2, x and x. On the next one we have 10x, so that's 1 and 10, 2 and 5 with an x. 2x and 2x. Hey, clicky clacky, knock it off. Alright, so I'm going to write a 2x in the front. What's 4 divided by 2? 2. You had x squared, you're taking an x out. That leaves you with an x. Minus 10 divided by 2?
5.
You had an x, you're taking it out. So you're done. Again, double distribute if you want to check your work. You do end up with where you started, so we're good. Number 16, I honestly wouldn't even bother with a list on number 16. What's the biggest number they have in common? What? 6. They're both 6, right? They have a 6 in common. How is that confusing? What does 6 have in common with 6? 6. Oh man, 666. Ugh. All right. Anyway, 6 is a GCF. If you want to make a list, obviously 6 will be in both lists. Obviously, it can't get bigger than 6 when you're talking about a 6. So 6 is a GCF. Write a 6 in the front. What's 6 divided by 6? 1, and you have the x, so 1x or just x. What's 6 divided by 6? 1, so you have a 1 in the back as well. If you're like, there's no way this is right, double distribute, or actually just single distribute on this one, and you'll be right back where you started. Alright, number 17, we have 2x squared, we have 14x, and we have 8. We got 1 and 2, xx, 1 and 14, 2 and 7, x, 1 and 8, 2 and 4. What do these have in common? 2. Any variables? Not on this one, nope. So divide by 2, divide by 2, divide by 2. Write the 2 in the front. 2 divided by 2 is 1, so you have 1x squared or just x squared. 14 divided by 2 is 7, keep the x. 8 divided by 2 is 4. Alright, 18. These problems are getting a little longer. A little harder. We have 8x to the third. We have 20x squared. And we have 12x. For the 8, we have 1 and 8, 2 and 4. XXX. Next we have 1 and 20, 2 and 10, 4 and 5, XX. And last we have 1 and 12, 2 and 6, 3 and 4 with an X. GCF.
4x.
4, 4, 4, X, X, X. So I am going to divide every single term in this polynomial by 4x. 4x goes in the front. Don't forget the number in the front. A lot of you know the process. You have all of it down. You do all the hard parts. You just forget to write the 4x part. Okay, don't forget to write the GCF in the front. The whole point of factoring is rewriting it as multiplication. If you forget the GCF, you're not multiplying it by anything. It doesn't make sense. All right, 8 divided by 4 is 2. You had x to the third. You're taking one of those x's out, so you get an x squared. In the middle, 20 divided by 4 is 5. You had x squared. You're taking one of them out, so you just have one x left. And then in the back, you have an x. You're taking it out. You also have a 12. You're dividing it by 4, so you just have a 3. Questions on that one? It's probably the most difficult one in the GCF section. Alright, last one, we have 6x. We have 15y. That is going to be 1 and 6, 2 and 3x, 1 and 15, 3 and 5y. In common, they have 3. Divide by 3. Divide by 3. Your answer will be 3 times 2x minus 5y. You didn't take out any variables, so leave the variables the same. You're just dividing each coefficient by 3. That is the entire GCF section. What are your questions on GCF? Alright, I think we can squeeze the first couple MA problems on the board. So remember, the third number in a trinomial is your M number. The second number is your A number. The M number is the one you find on your factor sheet. The factors of 16 are 1 and 16, 2 and 8, 4 and 4. In order to multiply to a positive number, the factors need to have the same sign. They'll have whatever sign is right here. So in this case, they're all going to be positive, so leave them alone. And then just go through the list and see which one adds to 8. The 4s. So I am going to do x plus 4 and x plus 4. What are your questions? Same thing on number 21. Our multiply number is 18. Our add number is 9. The 18 is positive, so the signs of our factors need to be the same. They both need to, in this case, be positive because they're adding to a positive. So I have 1 and 18, 2 and 9, and 3 and 6. Which one of those combinations adds to a positive 9? 3 and 6. Good. So I have x plus 3 and I have x plus 6. Now, when you answered that one, you said 6 and 3, but I said 3 and 6. Remember, order in this doesn't really matter as long as you have the signs right. So as long as they're both positive in this case, if you want to write the 6 in the front, that's fine. If you want to write 3 in the front, that's fine as long as you have a positive 3 and a positive. The only way to multiply and get a positive is either 2 positives or 2 negatives. In this case, they're both going to be negative because they have to add to a negative. So when I'm writing my factors of 25, I am going to go through and just think of them all as negatives. Now, which combination adds to negative 10?
5.
The 5s. So x minus 5 and x minus 5.
Okay, so why did that be 2 negatives?
The reason they're 2 negatives, because they multiply to positive 25. The only way to multiply to positive 25 is if they're both negatives or if they're both positives. In this case, they're both negatives, and I know that because they add to a negative 10. Alright, 23 is the same way. It multiplies to a positive 16, but adds to a negative 10. The only way to multiply to a positive but add to a negative is if they're both negative. So I'm going to think of it as negative 1 and negative 16, negative 2 and negative 8, and negative 4 and negative 4. Any of those combinations going to give me that negative 10 that I'm after. Yes, x minus 2, x minus 8. Now, whenever you have a third term that's negative, this is where I feel like they get a little extra tricky, because we need to multiply to a negative 8 and add to a negative 7. The only way to multiply to a negative number is if one's positive, one's negative. So there's really two ways to approach this. You could list the factors of 8 and then sort of reason your way through where the negatives need to go. The bigger number always takes this sign. So you can go through and make the bigger numbers negative if you can remember that rule. If you can't remember that rule, then just make the same list twice and give the other numbers the negative, and then check with your calculator to see which one works. In this case, it's actually the first one that I wrote. It's the positive 1 and the negative 8. So I have x plus 1, x minus 8. Or you could do x minus 8, x plus 1. That's the exact same answer. You just have to be careful that you don't do positive 8 and negative 1, because that would actually add to give us a positive 7. We want a negative 7. All right? Again, just like the GCF section, if you're unsure if your answer's right, distribute it back out. X times x is x squared. Then I'd have a minus 8x and a plus 1x. That would give me the negative 7x. And in the back, you get a negative 8. All right, same thing on the next one. My m number is negative. The only way to multiply and get a negative is one positive, one negative. Yours is actually a little different on your worksheet. Did you guys notice that? Yours says negative 2 here.
Yes.
Fix it, make it a negative 3. There's actually no way to add to a negative 2 on this one. That was a typo. I was waiting for someone to bring it up, but you know, you guys just never did. So yeah, change it to a negative 3. It should work out a lot neater for you. The ways to make it 10 are 1 and 10, 2 and 5. I know one of the factors in each pair needs to be negative. I'm going to make it this sign for the bigger one. So the bigger one is going to be a negative. The smaller one's going to be my positive. That's the only way to add and get a negative. Again, if you can't remember that, make the list twice and just give the other one the sign. Make negative 1, positive 10. Negative 2, positive 5. And see which one of all the lists works. You'll end up not using that second list really, but if it's helpful for you, go for it. This is the one that works. So we're going to have x plus 2, x minus 5. Questions? Alright, so the last two MAs, the third number is both negative, but the add number is positive now. So when the add number is positive, you want your bigger factor in each pair to be positive. But you still need one negative in each pair since it's going to multiply to give us a negative 15. So the ways to make a 15 are 1 and 15, 3 and 5. Again, I'm going to make the bigger one have this sign. So I'm going to put the negative with the smaller one. The winning combination here is the negative 3, so I have x minus 3, and the positive 5, so x plus 5. Same setup back here. You're multiplying to a negative number. That means one factor in each pair will be negative. the larger factor in each pair takes on this sign. Which means for this problem, I'm going to make my smaller ones negative. Which combination is going to add to that positive 4? 2 and 6. So I have x minus 2 and x plus 6. Questions? Yeah? So now we're in the dot section. Someone in my last class asked me if they could put the list of perfect squares on their factor sheet, and I said yes. So the list of perfect squares is over on the board right over there, like 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. If you want to put that on your factor sheet, you can. The answers that you get, like the 1 and the 4 and the 9 and the 16, those are the numbers you'll see in the dot section because those are perfect squares. Remember, the way we do perfect squares, you break up the first number into what number times itself gave you that number. So the way we make an x squared is x and x. The way we make a 49 is 7 and 7. One gets a plus, one gets a minus. Same thing in the back. We have a y and a y. We have a 10 and a 10. One gets a plus, one gets a minus. Raise your hand if you don't understand dots. It is like so important that you're all getting all the points for dots. This is going to be a very challenging test. I know that already. So I want to encourage you to get all the dots points because they're the easiest. 3 points apiece.
No, the easiest is
The dots are the easiest.
biology.
No, dots are even easier. All right, what number? I'm just going to focus on the second number now. The x part is kind of easy, I think. What number times itself makes an 81? 9. So I'm going to have an x plus 9 and x minus 9. If you like drawing the forks, you can. I know a lot of you don't, so I'm going to show a couple examples without the forks. What times itself makes a 1? 1. So I'll have x plus 1, x minus 1. What number times itself makes a 25?
5.
So x plus 5, x minus 5. I'll do the forks on this next one. What number?
You put a 1.
Hmm?
X minus 1.
Oh, Lord. Thank you for stopping me. Again, I'll do the forks just to show you the fork method as well. One gets a plus, one gets a minus. You should be getting the same answer. Some people prefer to draw the forks. Some people are annoyed by the forks, so whatever you think. All right, down at the bottom, we'll get x plus 6, x minus 6. And number 35, we'll get x plus 3 and x minus 3. Any questions on the dots? Remember, it's what number times itself gave you the first term. That goes in the front. What number times itself gave you the back term. That goes in the back. They're both binomials, so put them in parentheses. One gets a plus, one gets a minus. All right, we're going to jump down and I'm going to show you the bonuses. The bonuses are strictly for fun. They're actually both 2 steps each. There was a typo, so I'm going to fix that first. And then I'm going to show you it. You can do it the way it's written. It just makes it more like what you'll see tomorrow if I fix it for you. Okay, so the way A is written on your practice one, you can do that. It's y plus 4, y minus 4. But that's not really a bonus type question. So actually, I'm going to show you what it would look like if it was y to the 4th. So please change yours to y to the 4th. These are bonuses because you can do 2 methods on each problem. So for example, y to the 4th minus 16 is a difference of squares. When you factor it, you get y squared plus 4, y squared minus 4. What do you notice about y squared minus 4 back here? It's also a dots. So you could fork that one, right? Do y and y. And 2 and 2. So again, the reason these are bonuses is because you can factor each one twice. So if you are on a roll with factoring, give the bonuses a shot tomorrow. If you're barely getting through 1 to 35, don't even worry about these. These are just kind of cool, challenging problems if you want to give them a shot. You cannot factor the y squared plus 4 because it's not a difference of 2 squares. It's a sum of 2 squares. You can't factor sums of 2 squares. Alright, so that's the way you do part A of the bonus. It's 2 dots problems in one. Kind of cool if you're into dots. The next one is actually a GCF and an MA put together. So 3x is the GCF. When you divide each term by 3x, you get an x squared plus 6x plus 5 with the 3x in the front. Don't forget the 3x in the front. Then you could do MA method in the parentheses. See how this is an MA? Multiplies to 5, adds to 6. And the way you do that is x plus 5, x plus 1. So again, these are just for fun. If you're like, what is she talking about? Don't even worry about these. If you love factoring and this makes sense to you and you're getting really good at it, try these tomorrow. They're kind of just fun problems to challenge you. They're worth 4 bonus points, so do them if you want. Leave them blank if you want. Do you guys have any questions on what to expect for your test tomorrow?
How many questions again?
It is exactly like this. So 35 questions with 2 bonus questions. They're very similar to what's on the board. They're not the exact same problems, but same concept. It'll be factor completely, and they'll each have 2 methods that are possible. I won't tell you the 2 methods. You got to recognize them, and you got to do them correctly. So.